I've been working on restoring this machine for a couple of months. It has been an undertaking, but I'm very happy with the results, and it's really nice how the machine's cleaned up. And not only that, it works. That's the nicest thing. I have a multi-part series plan showing how I did all of the work on this machine. What I want to show you today is how I got the floppy drive working. The original drive that came with this machine ultimately failed, but I was able to find a different one and adapt it to work with this machine. I've tried to break this into 3 different segments. The first is a deep dive on the original floppy disk drive that came with the drum machine. Now, this had trouble working at first, and I spent a whole bunch of time taking it apart, trying to figure out what was going on internally. I really went to town on this one. Tons of technical detail. The second segment, I'm going to focus on adapting a separate drive in order to work with the drum machine. This one's a little bit more straightforward, and it's kind of fun, some electronics work. Final phase, I'll be talking about using a Gotek, which is a modern emulator for floppy disk drives. The best part about this, no moving parts, and all of your disk drive storage is actually on a little USB key. And it has an OLED and a rotary knob. It's awesome. So those are the 3 phases. I'm afraid it's not looking very good for this stepper motor. Long story short, top head could read and write, and the bottom kind of failed. And in trying to troubleshoot, this motor just kind of died. So we should call boys to men, because it's the end of the road for this disk drive. Oh my God, what now? Oh no. So while starting up, it loads files from floppy disk. So that's like all sequences and sounds. And I'll spare you the wait, but this takes forever. All right, loading is finished, and we now have the finest loops from 1988 Ultimate Hypnus. And there are 29 different demos, I think. So we'll roll through a couple of them here. Dang. Oh, wow. Oh, boy. I'm going to have my work cut out for me, that's for sure. Yikes. These original discs were 2DD. There are various terms for these, but that's double density. And you'll note the hole, only one hole here. That's the right protect. High density is like 1.44 megabytes. Double density is 720 or 720K. So this is an HD 1.4 meg disc. So what I need to do to make this look like a double density is we cover up the density hole. So just a little tape there. Watch this transformation. Look at that. Let's see if I can just save all sounds for. There goes the drive doing something. Okay. Not formatted or is bad. I haven't formatted this yet, so let's format 7. Now this drive, this is the original drive. This is a 38-year-old, whatever, 7-year-old drive. Let's see. I haven't tested, cleaned it, nothing. Oh no. Okay, it says unusable since a defect was found in the area reserved for the file directory. All right, we got one more. Yeah, there we go. This one has a little lock icon on it. So that means not write protected. We should be able to write to this disk. But, let's see. No. Okay, it's saying the same thing. All right, it's taken me an hour. I actually busted out a 20-year-old laptop for this. I was really trying to get this disk drive to work. And it seems to be that the drive spins. You can hear it kind of clunking around. It says it's saving. And then it kind of doesn't work. But let's see. Oh, yeah, I see. So now maybe it's trying to write the file and then verify it and failing to read it back. Maybe I can try a different drive. But in all honesty, it might be just easiest if I just swap in this Gotek, call it a day. But maybe I'll try to clean the floppy. I don't know. I like a challenge. I'm going to pull the floppy drive. Trying to format doesn't work. And trying to read and write files doesn't work. So I figure, what the heck? Let's take it apart. Take a look. So this looks to be, these drives might be kind of particular, right? Mitsubishi MF353C. Yeah, look at that. Yuck. Floppy drives tend to have this. There's a clip here in the whole thing. Let's see. There we go. And that's going to open that up. Good. Anything perfect. Okay. I'm going to have to glue that later. Damn it. Oh, there's that. Okay. That's free. I recall it being pretty smooth. Yeah, and then eject. That's pretty good. So I think, let's assume this is just dirty. It just needs cleaning. For those of you who haven't seen a floppy drive in a minute, maybe ever, here's a refresher. So disk goes in. This is the top portion of the drive head. There's a top and a bottom, double-sided. This is a stepper motor which drives a little worm gear that moves the head back and forward. Those are across the tracks. That's the physical part of the disc. This is a little tension spring that holds the head and keeps it down, basically. You can tinker with this a little bit, but it can be dangerous. There's a whole alignment thing you don't want to mess with. If it ain't broke, don't fix it. These are little ribbon cables that go to the read and write heads on the drive. So that's the data. And then there's a similar thing here that might be to the motor that actually spins the drive. Looks like this is the stepper motor here. That's a separate thing. It's not super clear what that one is. But there's a larger motor somewhere that, oh yeah, here, so this whole thing spins. Little capacitors here. Hopefully everything there is working. This is your typical floppy drive 34-pin interface. So that connects to typically a computer. There's your 5 volts and sometimes I think 12 volt power. And then it's really hard to see, but here are the jumpers. Not too many drives have these as they got newer, which allows you to set the drive select. So this is a whole DS0, 1, 2, 3. It's going to be really hard to see that. But one of the important things with these drives, and this is what trips some folks up when they're doing replacements, is the standard is drive select 1, DS1. And then there's normally a twist in the floppy cable. So normally all drives are set to DS1, and there's a twist, and then it connects to a computer, and that's drive A. So with this, there's no twist, and drive 0 is like drive A here. And I think, from what I've been reading online, there's another thing about the disk ready, disk change signal, which, long story, this should already be configured. But looks like it just needs cleaning first, so let's get to that. It smells like the old damp towel, musty basement, something that got really damp and wet and still smells bad. Yeah. Patron saint of circuit board cleaning, isopropyl alcohol, 99%. I recommend. So I'm going to see if I can get in there. There we go. And very gently go across the drive head. This might actually not be very practical. Just going to go for it this way. Gentle. Now that little thing is kind of suspended on a little web mechanism of wire, so it is really important to be careful there. And then the top head you also just want to be really careful with. Don't snag cotton on stuff. Oh, no, that didn't look all that bad. Now I'm just going to go to town on this front grossness here. Might need a little bit of grease here. It can smoothen out things, but you don't want too much because that can attract dirt and make things worse. So, I don't know, maybe that's time for a test already. I'm taking the top off, Q-tip on the heads, so give this a shot. If this doesn't work, that's fine. I can try connecting this to a desktop computer adapter, like an actual computer or a Greaseweazle, and then see if I can get any I/O from it that way. Troubleshoot further. And in the meantime, the ultimate goal, either way, is to replace this with Gotek. So do USB, emulate floppies all day. Should be easy to set up. Try popping this up here. Floppy interface pointing downward as it was. Set that right there. Okay. So I'm going to save all sequences and whatnot. Save it. No. All right, let's try format. Yeah. No. All right, defect was found in the file directory. Out of curiosity, let's see if the floppy controller in this thing can talk to this. If this can save to this, then we know at least the floppy brains in the MPC are good. It's possible that the floppy stuff could have trouble. We're going to go after this little bit here. Not too much, but woo. Yeah, that's probably too much. And maybe a tiny bit on the this piece as well. Just don't want to make a mess, and I don't want to leave residue on there either. So just a minimal amount should be okay. And I think I can, no disc. That ought to be plenty. More isopropyl alcohol cleaning. This thing is gross. I've certainly seen worse, but it definitely has what appears to be moisture gunk on it. So I'm curious to see what's underneath here. Let's take a look. Track 0, calibration stuff is separate. It's attached to the frame. I know some people have talked about in other YouTube videos how You shouldn't move this circuit board because it might affect the calibration of the drive. Best I can tell, this drive calibration is not dependent on the positioning of this circuit board. Let's see what it's underneath. Oh, yeah, need to remove these. That's important. I'm going to need 2 hands to do it, I think. Yeah. Stay tuned. All right, I'm making progress here. So that thing does, there we go. 16 volts, 10, and then this, I think, is the same. Yeah, both 16 volts, 10 microfarads. Wow. Okay. Get the ESR meter out. Okay, let's call it 1.657, okay. Ooh, spicy. 3.55. Okay, let's check those. So according to this, 16 volts, 10 microfarads, we're allowed up to 8 ohms on the ESR before it's considered, worst case Ontario, bad. So 1 and 3 is totally within range according to this. So those are okay, in which case I think my work on this side is done. Okay, disc reads are still working. I haven't broken anything yet. All right, normally I do a whole screen capture and whatnot, but anyways, here's trying to write to the floppy disk drive and showing how it's failing, erasing, and then trying to write to track 0, failed to verify. So unfortunately, my cleanup attempts have not improved the writing situation to the disk. So I'm a little bit stumped as to what I should try next. This is a Greaseweazle, this has a cover on it, but anyways, this is a modern way to connect a disk drive to a modern computer. Here's a somewhat typical 3.5-inch floppy drive. You connect your power there, and then your floppy cable connects to the drive. Now, depending if your classic A drive set up the way I like to think of it, you have the twist in the cable. So the A drive is after the twist, okay? And then the B drive is before the twist. These are 3.5, that's a 5.25-inch edge connector. So in this case, this drive doesn't want a twist. It wants a direct connection, no twist. And the other important thing here is you can see that. There's a little dotted line here. That indicates pin number 1. And what I like to do is I'll draw a little thingy here. Usually there's an arrow. I also draw that. There's your line to indicate that's pin 1. So pin 1's there. You also have notches and things on certain cables. And the reason that's important here is you want to look at these pins and see there's a notch. But where's pin 1 and 2? So that's 2, pin 1's on the other side. So the important thing to do, never mind the notch, this is a wacky drive. You take a look at where pin 1 is and line it up there. So you'll notice, maybe that's probably not clear, but on this drive, here's pin 34, here's pin 2. So this one actually connects this way, and maybe there would be a notch that fits in there. Whereas, note, this drive, you gotta flip the cable around this way. So pay careful attention to which way these things need to go. More tests today on capacitors on this floppy drive. The number that it shows determines whether or not the capacitor is still usable. Now, I need some better probes, but this one is a little too bulky for getting at these legs on these little guys. Let's call that 2.16. Now that should be totally fine. I think that's a 16 volt. So I'm at 1.6. Totally fine. Just a quick note, if you decide to bend these little capacitors to check the values, just keep in mind they might just come right off the board. Whoops. Oh, okay. 16 volts, 10 microfarads. Jeez. What a difference a flash makes. Okay, 16 volts, 22 microfarads. Just tested that one. It was 1.6. Got the flash on now, pardon the harsh lighting, but hey, easier to see. Look at that. 4.41 ohms. I think it's, Adam Savage said it's, when you write it down, it's science. Something to that effect. ESR on this might be at the threshold for a bad cap. And according to just a quick online search, the maximum worst case is 4.5. So that's possibly bad. So check the other ones. See what else we find here. 3.4. All right, this is the worst looking capacitor by a long shot. 2.2 microfarads, 50 volts. And the measured ESR was 3.4 ohms. 1.43. 0.5. Those are good. Or at least they're within acceptable range. I'm going to see this cap, which I think might be bad, if I've got a better one. When I last was poking around at some of these, it seemed like a lot of these were bad, or at least not within acceptable values. So I want 1 microfarad, 50 volts. Let's see if that's correct. I mean, assuming that I'm reading this correctly, that's already at the maximum ESR. So I wouldn't use this. Let's try some other ones. All right, this one's a little bit better. 3.73, the max. Maybe this is fine, but they're just not low ESR. But I think I want low ESR caps. Again, I'm not a professional. I could be wrong about all this. So I'm going to go with this one. I'm going to choose the 3.58. We'll desolder this bad boy. Try swapping it. I don't know. We'll see what happens. Thank you. Take a look at my quote-unquote handiwork. You know what? I'm pretty sure I've done a lot worse. So there's our positive. And there's our negative. Try this thing on the Greaseweazle and see if it makes any difference. I'm not going to hold my breath, but it's worth a shot. I'm not proud of this, but it's what happened. I had taken this thing and I'd cleaned the head and I'd poked around and I put a disc in and the head moved and then it made a terrible grinding sound and I thought, well, what is this stuck? Took the disc out, it's fine. Put a disc back in, noise. Well, there's your problem. So I feel a little bit bad, but somehow that's just come completely out. So maybe I just take this as an opportunity to try worst case Ontario, last resort option, take that whole top head off and try my best. Because this thing just will not write no matter what. So this is my last ditch effort. So be it. Better lighting here. It's looking pretty tidy. I would say very tidy. Wow, yeah. I think that actually, that PlastX stuff, that really tidied that up. I might go over that again one more time just to be safe, but the top head seems to be happy. So the question is, what's going on now with the bottom head? I'd say that's looking pretty good. Please excuse this mess. I have an oscilloscope. This is connected to some test points on this floppy drive, which I'm trying to recalibrate. It's having trouble reading further out into the disk. So I'm going to demonstrate here. Seek to track 0. Move to the first track through the first 5 tracks. Read the data. This is looking good. Greaseweazle here says I'm able to read those tracks, no problem. Now, if I seek to the last 5 tracks on the drive, you'll notice the signal is a little weaker. I'm not sure if this is showing both heads, top and bottom. It's not clear on what's going on there. I would expect that if one's working, one's not, there'd be a significant difference, but it seems like they're both weak. But either way, I could show you separately, but the Greaseweazle is saying, hey, I can't read the bottom head. What I plan to do is adjust the track 0 sensor. Here's the track 0 sensor. This is an opto isolator, as far as I know. So basically, it's a light sensor. So there's a beam of light. When the drive crosses that, this says, hey, something's in my way. And the drive knows it's a track 0. Now, this can be adjusted quite easily using a little screwdriver. So it's currently really far out. And so I suspect I've got a lot of room to work with here. And I suspect that the alignment can be made much nicer to what track 0 actually is. And I suspect that the heads are a fair bit, they work in here, but by the time they're out here, like that little distance just kills reading further out. So what I'm going to try doing is adjusting this and then reading halfway out and then further out of drive and see if I can get those last tracks to be readable. And in theory, the scope should confirm it. Fair disclaimer, there's a certain amount of guesswork here, and this may or may not totally fail. So what I'm going to do is tell the drive to seek to track 30 just to get away from the track 0 sensor. So we're going to make sure we're off 0, then go back to 0, hit this sort of breakpoint to reset the positioning. Then we're going to go to a certain way out, and I'm going to go to the end of the drive and see if we can get a read. So here's 75 through 79. Now that's just the top head, so that's fine. Let's try just the bottom head now. No good. So you can see it retrying. It fails, then it moves forward one track. So another way to do this would be to rotate the stepper motor, but I think you still have to seek back and forth to reset the positioning. I don't know if there's any real easy way other than rotating this while the drive's moving to change the alignment. So there's a little bit of a guessing game involved. Okay. Now it's saying can't find track 0. All right, that's not good. Let me do a reset just to be safe. Track 0 not found. Well, I think I might have just gone too far. This screws as far out as it can go. That means the sensor is as far out as it can go. And so it should be over aggressive. Now, there we go. What are we getting now? Okay, that took way too long. Okay, now we are not reading anything. Let's see if we're getting anything on the top head. So I think at this point, I think what's happening is this is coming too far back and the drive head is positioned entirely off. So that's good to know. Let's see what the first couple tracks look like. Okay, note the strength there. And then here is what the end looks like. See how there's a difference in amplitude there. Here's reading this whole disc, start to finish. Just the top head only, which should work. So watch the waveform here. I also forget if this might be the thing, there might be less amplitude right coercion, I forget the term, on the inside tracks of the disc. The outside is stronger. This goes beyond my current knowledge, so maybe that's fine. No read errors. That was 100%, 720 sectors. Top head works fine. So here's the inner 5 tracks. Tracks 1 through 5. 260 some millivolts peak to peak. And then here's the last 5 tracks, 150 to 180 something millivolts peak to peak. So it does seem like this is on a commercial disk. At least on this particular drive, there's a bit of a drop in reading, a difference in reading the outer versus inner tracks amplitude of the signal. So maybe that's okay, or maybe, you could nitpick and try to align that a little bit better. But either way, it's 100% readable by the drive, so that works. I'm going to write 720K disk image here. Now, I've wired up test points 1 and 2 to the scope, and I'm not exactly sure what's going on here, but the waveforms look like a mirror of each other. Whoa. I didn't mean to turn that off. 1 second. So I'm guessing those are the bits being written to the disk and then read as they're verified. If I turn off, I'm going to abort the write and I'm going to say no verify. I think that's how that works. Yeah. So now it's writing and it's moving to the next track without stopping to read back and verify. And I think that makes sense. So let's stop that. Now, if I write regularly again, you see on and off. Let's see if I can do this. Here's test point 3. And I think this is now just counting as it's moving across tracks. I'm not sure. Let's see if auto will work. Reading the commercial Armor Alley disk in another drive. This is actually a Sony, I believe it's a 920 or something. I bought this off Amazon for $14, and I think somebody just put a sticker on it and branded it something else. But anyway, neither here nor there. It has some interesting test pins. So let's see what we get. Aha. All right, it looks like I've got data, and then that's either the track seek or direction, head step or head direction. So far, reading is good up to track 20, and holy cow, 400 and something millivolts peak to peak. That is super strong signal, if I'm seeing things correctly. So that is phenomenal. I don't know if different drives amplify the head signals more than others or what, but that is a very strong peak to peak. And it does look like that's decreasing somewhat, but I mean, it's still over 300. All right, we're about 320 millivolts, track 72 now. All right, so reads complete, 100%. And that was really interesting how this had a very strong signal throughout. And just for fun, I'm going to try writing the Armor Alley image I just read to this other disk. And let's see what this thing does. This disk has had some trouble, so we'll see what happens here. But I mean, yeah, look at that. Over 500 millivolts peak to peak for a moment there. 60, still hitting at least, well, close to 300 millivolts peak to peak. Okay, track 70. There's our failure. 71. Okay, this disk is, I think it's just bad. But yeah, failed to write and then it gives up. Let me try this again just quickly with without the verify option. So Greaseweazle will write a track and then it's not going to bother trying to read it back. So let's see how that looks on the display. I think it's just going to be, yeah, seek and then lots of quick writes. And there's no read back, as opposed to, here's what it looks like, reading, writing and reading. All right, just for completeness sake, I've written that image onto a different disk, all 80 tracks, no problem. Reading back the image that I just wrote, I just want to note, getting over 550 millivolts peak to peak. That's kind of awesome. So this seems like this Sony drive really reads and writes strong. I'm assuming that's a good thing. But yeah, good numbers. All right, summarizing this hack job I've done on this Sony drive just to get some stuff on the oscilloscope. These are the test points. RF was, as far as I could tell, the read head data. And then I got one ground, TRK0, track 0. I believe that would kind of pulse every time the drive would move. So it wasn't clear if that, anyway, I don't know. It wasn't that interesting. X ADJ, I'm guessing is X adjust, but I don't know if that really provided anything interesting while this was running. Anyway, there's that. I've been trying to test some of the capacitors, the surface mount caps on this board. And I think, again, I'm not an expert, but I've been just doing a resistance test. So here's 121 kilo ohms. Note these are capacitors, which I believe are not polarized. So there's 122. And then this one, which I've marked up already, shows overload or OL, so like open circuit. So I'm wondering, either this isn't connected to anything or it's bad. And as far as I can tell, that's the only one on the board that does this. All the others register something. Hopefully you can see that. Again, this is a shot in the dark. On the flip side of this, I believe this is a PLL chip, which is a phase locked loop. This is the thing that encodes and decodes floppy data. This, I believe, is related to motor control. Have to confirm that. This is the read-write signal amplifier. So the very weak signals that come off the read-write heads go through this thing and are amplified. So if there were something bad with the right, there seems to be something wrong with the right cycle. Reads are fine, writes fail. So I'm wondering if there's an issue with this. Now, so another thing to look at are, there are a few diodes here, which, as far as I know, do involve the read-write stuff. And so I believe what I'm supposed to see across one way is, yeah, about 6.6 volts. And then if we reverse polarity, we should not get any reading. That is open load. So that one looks to be good. Now, what's interesting is this bad boy up here, which I believe is the same type diode, 0.625. And then the other way, look at that. We got 3 volts across it. So that, to me, suggests that this bad boy might be bad. Again, wild guess with the right stuff failing. Done a little poking around on the data sheet for this read-write amplifier circuit. Now check this out. This line here, trace, goes to 3, 4, 5, 6, pin 27. Pin 27, according to the data sheet for this, is write current control. I think WCCONT. So, if there's no write current, that might have something to do with why writes aren't working. So, maybe I just need to visit the local electronics shop and get myself a handful of those. Now I'm curious. It occurred to me that I didn't check more pins on this thing to see whether there are other pins that do light up here. So it looks like pin, that's, let's see, 1 to 11, so there's 11, 10, no, pin 9. And there was 1 or 2 here as well, 22, 20, 19, okay. And then as originally found, 27. So those are presumably write related as well. I don't have the info right now, but I will put those on the screen or add them or something. This drive is giving me trouble. It has trouble reading, and it just won't write at all. So I'm pulling out the heavy equipment. Hi, Uncle. You'll note this is a high-quality product. Instructions say, plug the cord into power source, place the demagnetizer tip against the recording head, move the tip over the entire pole surface of the head for about 1 second, then move it slowly away from the head and disconnect it. Be careful not to overheat. Do not leave connected for more than 5 minutes at a time. If it gets too hot to hold comfortably, disconnect it. Okay, well, I can do that. Okay, it's on, allegedly. Oh, I can feel a little, it's vibrating a little bit. All right. Slowly bring it away, turn off. Okay, well, that was easy. Yeah, there's a retry on 56. Okay. I'm going to say there's no difference there. Now let's see if write has changed at all. Failure, right? All right. One other thing I haven't tried is actually just degaussing a whole disc. So I'm gonna give that a shot. Nope. Verify failure. I got an unknown mark that time. That's a little different. Time for something else. Something I've seen on I think it's like Retrotech UK channel. Forgive me, I will get the name and the link in the description later. He uses this PlastX, which could help to restore plastic and scratches and whatnot. So if you have a drive that's really gone through the ringer, per se, perhaps like this one, and it's had some gunk on it that it's actually damaged the plastic on the heads, this might be of interest. Now, I'm pretty sure I barely need any of this to fix up one of these things, or at least apply. So what do the instructions say? As one of my other favorite YouTube channels says, 1 moment please. Much brighter. Liberally apply that. And then get it off before it dries. I'm not sure how exciting this might be to actually watch, so bear with me. I'm going to want to go over these with IPA, I think, just to make sure I really got them. The last thing I want is plastic cleaner residue getting on the disc. Isopropyl alcohol. Boy, that stuff really has a soapy, fragrant smell to it. I wonder what's in there. I think think I've got a lead on this. So I loosened up the drive head, and check this out. I'm just reading the top head here, which is H equals 1. And look at the strength of this. It's peak to peak. It's over 100 millivolts. That is awesome. I'm going to intentionally mess it up so I can show you the effect of getting it wrong and then how it looks when you get it right on the scope. Okay, here we go. Let's mess it up. So here we go. I'm going to start with a nice reading. Now look at this. Oh, losing the signal. So drive's complaining, okay, unexpected sector and all this. I'm just going to very carefully move it back toward the middle. Look at that. And then it starts picking up and you hear it moving along. That's all it is. So once you have that, just very carefully, I didn't quite nail it. I really had it earlier. Let's do that again. Frig, I had it, and then I reset it for the purpose of the demo. Oh, that's okay. Unexpected sectors already. Too bad, because the signal looks awesome. I think I got it. 6, 7, 8, 9. Okay, let's start that from the beginning just to do one more pass, make sure I got 100% read. So a little over 100 millivolts peak to peak. 110 I saw there for a second, that's nice. Track 40. Okay, there it is, 100% read. Let's lock it in. So while it's not moving, just gonna hope that holds. To show the context here, here's what we're looking at software-wise. Greaseweazle. Now the question is, what the heck am I gonna do about the bottom? So let's see, that's head 1. So head 0 is the bottom head. Let's see what it's doing, because I think these things are misaligned right now. Here's what 0 is doing. Oh God. Nothing. It's completely misaligned. Or broken. I mean, maybe I broke it. I don't know. Well, this warrants perhaps more investigation, unfortunately. Boo. Here's writing a disk. Test pins 1 and 3. No verification. I'm not quite sure what the heck is going on here. But it looks like one write is, if those are writes or reads, one's really weak, one's really strong. So I'm a little confused. Now if I do this without verifying, that was an attempt to write and verify and then fail. So, yeah, bit of a loss. Now if I do, this is on a non-commercial disk, trying to write. Now if I try to read, first couple tracks are bad on this disk. So maybe it's reading, so maybe the bottom head is actually working, but it's very weak compared to the top. I suspect I've just got the leads backwards, but you can see the difference in the signals there, I think. So if I were to try reading only the bottom head. I'm not sure if that's it. But here's what head 1 only looks like. Maybe it always shows both. So maybe that's the bottom and that's the top. This is where, again, I'm a little lost. All right, so with that done, what if I go back to just head 0, just the bottom? So it just seems like a lot of noise. Mystery. I'm gonna try poking around the bottom head tomorrow. Maybe it's not making good contact with the disc or something. I don't know. It used to work at least a bit. Writes are still totally messed up. Double density drive, commercial disc. Let's see what the read looks like. Top head only. All right, notice that we're getting 80 millivolts peak to peak. 70. Notice the signal dropping here. 80. Done. 100%. Flawless victory. Now I'm going to try to read the bottom head. Just watch what happens here. Absolute disaster. Unknown mark. Failure. Signals maybe 20 millivolts on the outside. That's no good. So what I need to do is figure out what's going on with that. Now let's see if I just try the last 10 tracks. What do I get signal-wise? Not much worse, honestly. But it's still having trouble reading. So something is wrong. And I'm hoping it's just a physical contact issue. Like the bottom head just needs to be physically raised or something. So I'm going to pull the top head. And yeah, I'm going to have to realign it, but I'm becoming rather skilled at that. Don't mind at all, it's kind of fun. Take a look at the bottom head again. It's a little mark on there. But other than that, I would say that's looking pretty tidy. I would say very tidy. All right, there's a close-up of the bottom drive head. I think this is looking pretty tidy. The PlastX, I think, really cleaned this up nicely. Let's see if we can zoom in even a little bit more. Gratuitous close-up. But it's looking pretty good. Now, my guess is that this is just slightly, I don't think that it's misaligned, but I think what I'm going to try doing is to loosen this whole thing up, pop it off there, and reseat it, and maybe just bring it up a little bit. And with any luck, that will maybe bring it into better contact with the surface of the disc. And my hope is that that's what's causing the read trouble. The other thing I want to do is test for continuity. Maybe I can check to make sure that there aren't any loose wires. For comparison's sake, here's the top head. Maybe a little speck, like a scratch or something stuck on there. So I wonder, while I'm in here, let's see if the cotton. Aha! Yeah, look at that. Cleaned right off. So it's worth paying attention to those things. But this is looking pretty clean as well. Part of me says, if it ain't broke, don't fix it. This thing is currently reading 100% of disk with no errors, top side at least. So I'm going to leave this be and then just focus on the bottom head. Back on the bottom head here. So I'm going to try a little Q-tip action. Oh, we can get that gunk off there too. Let's just see if I can carefully pop that thing loose, perhaps. And let's just see. Just want to be careful. I don't want to bend anything here. Maybe, maybe the thing to do is actually just bend this thing upward a bit. Maybe that's all it really needs. Just to lift it. Could see if we get continuity beeping off here. Sure do. Okay. Yep. Well, it seems everything's pretty well connected here. Not the fourth one, though. Okay, there's 1, 2, 3. Okay. So it's just right. This is the opposite direction. That's fine. So if I do this one, they all gonna get the same results. All right, what's resistance? Again, not sure if these measuring resistance is the way to go, but let's just, I don't know, see what we see. 21 ohms, about 14.8 ohms, and 28 ohms. Okay, that's also 28.7. 14.6, if I saw that settling. 21 points. All right, well, I'm just gonna say, I don't know that these numbers mean very much, but I think these are both working. All right. So it says to apply this, and then you polish it before it dries. So before drying, really get in there. Then I'm going to clean with IPA. Sorry for bumping the camera. And then the last thing, you know what? I can see that's on an angle now. I've pressed that way down or something. Isopropyl once again. Whoa, did you see that? Well, that was not good. Okay. Oh boy. I might have just broken or split the head. Okay, I want to be real careful about that. Yeesh. It's not the prettiest looking thing in the world. But I think it's the top surface that matters. So as long as that's looking okay, I think that's okay. Maybe a little bit of a gap there. Ugh, it's really interesting. Moved and adjusted still. Yeah. All right, well, I don't know if something was, there was a bit of plastic or something that was kicking around in there, but I put a little grease on the rails, the worm gear on the stepper motor, and reset Greaseweazle with track 0. And now it seems like it's okay again, so mystery. Let's start from the beginning. Oh, that's looking good, numbers wise, but it's saying unexpected. So let's see, I wonder, can I push this whole thing back? Or, oh yeah, from the top. Retry. Oh, hey, we got a read. Okay, all of a sudden we're looking good. Okay, retry. Got 70 millivolts, peak to peak. Let's try just straightening it a little bit. Yeah, 1 over 100. Okay. And we are reading. Okay, that finished. It's 98% disk read. Let's try it from the top. It looks like the signal's dropping from 100 to, yeah, under 50 millivolts. But I mean, read the entire disk, so okay, I'm going to try to just not have anything move. It might also affect the read because that's pressure, I think. So let's try that again and see. Are we still okay? We're not quite hitting 100 now. There's a retry. Okay. One retry on 72. I say, I had it so good. Let's just try to, just a little bit. See if we get that signal to over 100. Restart. Okay. Yeah. Look at that. 120, 130. Oh, yeah. Okay. Restart from the top. Oh, that's great. 130. I think that's one of the best I've had yet. So yeah, as you can see, this is quite sensitive. What you really need is some little tiny mechanism with a screw that, like an expanding, you know, like a little thing like that would be great. Oh, that's so much better. All right, so I read the whole disk, got down to 60 something at the end. That's fine by me. Let me try tightening it up and seeing what happens. Without over tightening, let's see. 130 again, 135. I'll take it. Fantastic. Okay. Red, done, 100%. Fantastic. Okay, now the scary part. Let's try bottom head. I think this is toast. There's something wrong, but let's see. Head 0, bottom head only. Okay, unknown mark. And then if you look at the peak to peak, it's 20. So I don't want to push this, but this is where I wonder if pressure on the disc would help at all. Nope. Don't want to scratch it. Sort of. Okay. I've got a slightly crazier idea here, since I'm running out of, shall we say, more logical options. So I'm going to do something maybe not smart. And I'm going to take that, and I'm going to take the bottom head and have it feed into the amplifier for the top. Now, this could be bad because maybe things are different. And maybe this signal going in here will cause trouble. But at this point, if something breaks, I'm okay. I just want to see if this reads any differently on here now. So this will help to rule out if there's an amplification issue from the bottom side. Let's see what we get. No real difference. 20. Okay, so this is, I'm going to say this is good. This infers that the amplification circuitry is doing its job. Let's just double check that everything's working still. Okay, top head reading. Bottom head still is not. All right, it's another day. I'm back at this again. So the plan for today is to remove the top head. We're going to get access to both the top and the bottom, but I'm most interested in the bottom. I'm going to show why. I want to glue this into place. I messed up a little bit the other day. I accidentally pulled that out. Whoops. Gotta be careful with those cables, but I believe these are fairly robust devices. I have managed to somewhat inadvertently pop this thing off. So let's take a... So while we're in there, let's get a close-up of that. Kind of looks like a coin. It's cool. Wow. So what I'm gonna do, as I mentioned, is we're gonna glue this little thing back into place, because that popped off the top. Do a review and I guess clean on the heads while curing, so that should be fine. Perfect. Careful of how much I actually put down, just like that's it. That's all you need, I think. Just enough to wet the rail or surface there. Bring that down nice and easy. This is what I did on the top. All right, here I was thinking, an hour and a half would be ready to roll, but no, this glue needs 24 hours to cure, so I'm just gonna have to hurry up and wait. All right, I don't want to say I'm impatient. I'm just excited. Of course, who am I kidding? I'm somewhat impatient. It's been 5 hours. I've been poking around. I think this glue is holding up just fine. I feel like that bottom, this looks ever so slightly misaligned, but again, it wasn't working at all before, so I can't help it. Let's test it. Let's test it out and see what happens. Sync to track 0. It's gonna complain. Track 0 not found for some reason. I'm gonna tell it, all right, move all the way to 80. And it is, as you can hear, not very happy at all. Might need to move the track 0 sensor way out so that it gets picked up. Well, there might also be an issue with the drive getting stuck somehow, so I can try just moving this. I don't know why this happened before. Try moving this, and I know I shouldn't be using a Q-tip, but I need something kind of grippy. Let's just see if I can get this to move at all. So it seems, oh, there we go. Step motor might have been just binding a little bit. So that's coming forward now. 4 life choices. I don't think that's binding on anything, but I don't know, maybe it doesn't take much to get this to stick. I'm not sure what I've done here, but I've been poking around this drive. Tried sort of grabbing and moving the step motor drive shaft, and I might be binding up or something. Now there it goes. I don't understand. I wonder if there's something loose. All right, well, let's not jinx it, I guess. Damn it, okay. And what is happening? I think the motor's binding up. It seems to me like it's trying to move and it's stuck, which would suggest that something else is wrong here, like a mechanical issue. Yeah, here we go. So it's spinning the disc and we're reading a signal. And so this may or may not be helpful here, but an interesting thing is that I can just keep this going and then I can move the head around, and I might not be able to confirm if it's the right sectors, but at least I can get an idea of, hey, am I reading a strong signal? So while staying on the same track, see, so that in and of itself is kind of interesting. So let's see if I can loosen this. And just spin. So knowing this, now if I can realign to the biggest possible. There it is. Look at that. Isn't that? Oh, that's beautiful. Okay, now, does that read? Close. Okay. Well, wait a minute. It says, ignoring unexpected sector, cylinder 0, head 1. Oh, I see. It's not reading track 0. It's getting track 0 when it's wanting track 1, 1. So that means it's too far back. So I have to nudge this ever so slightly forward. Okay, crap. Okay. I just slightly... This could probably be fixed by stepper motor too, but I'm just going to see. There. Okay. Now, go back to the beginning. Now it's off center. That's okay. Let's go back to 0. And okay, we're at 0. Now I want to sit and rotate, and now find the signal again. It must be way off here. Okay, there we go. You know what it might be? I wonder if it's in between tracks, it's actually trying to read off the bottom head sometimes. Okay, it's showing the top head now. Yeah, okay, I think there's something funny going on there. So you see now it looks nice. Okay. Okay, strong signal, but unexpected. So it's behind 1 again. All right, so we're gonna pull it forward again. Not sure if I've got that. I don't think that's coming any more forward. Okay, let's try that one more time. It's reading now. Okay. Awesome. And strong signal. Okay, let me try to not touch anything. Okay. Okay, yes, it sure is unexpected. Darn it, okay. All right, time to pull out the big guns and adjust the stepper motor. So loosening and turning this thing will affect the micro alignment, I should say fine grain alignment of the drive motor head, because it's going back and forth. So at this point, I think I need to move it just a fraction of some portion of a millimeter to get this thing on track and lined up properly. I'm going to try to sort of, I don't know if it's going to work at all, but I'm going to try to mark the original layout of this thing. Come on. Oh, there it goes. Okay. Okay, that's all I need. It moved. Okay, the rough plan here is, I think if I rotate this thing, the next time it moves, it's going to be affected. So I might be screwing up the track 0 stuff again. We're adjusting the stepper motor. Start reading from the top. That's looking nice. I bet you I could do a little better. So we got unexpected sectors. Sector 3. 1 when reading 0, etc., etc. So I think I'm going to roll back this way. Ugh. Okay, try this again. Unexpected sector 1. I'm going to go a little further back here. Oh, the other thing I should do, actually, no. I need to do a seek, first of all, to like 10. And then back to 0. And finally read, just to be sure I'm going to realign. Aha, now it's complaining about track 0. Classic. The signal's really good though, so if it's on 1, that means this is forward. So maybe I need to move this back a bit as well. Let's just start tinkering with this. again. That's way the heck off. Nice signal though. Still unexpected. Oh, here we go. Had it for a sec there. 1 out of 9. 6 of 9. I wonder if I turn this back a bit now. There we go. Okay, 6 of 9. Okay, I'm going to go a little bit more back. There we go, 9 of 9. So, I'm going to move a little bit more. Each time I turn this, remember, it is adjusting how far this thing moves. So it should be realigning as I turn it. Okay, this is good. Let's start. Let's let it run all the way through and see what happens. Okay, retry on 52 for a minute there. Signal's still looking pretty good. Okay, let's start from the top. Oh no, not again. Man, I don't know what is going on with this track 0. It's like the track 0 sensor is failing or something. Something is not right there. Okay, now we're missing sectors and whatnot. So, still red. Signals medium rare. Okay, I'm gonna move this in just a little. There. Now. 5 of 9. Let's see. It's reading okay, but it was off at the beginning there. I think that's this being a little off. So I'm going to go interactive style here. Pretty good. Over 100. Can I do better? Nope, lost it. Way off. Okay, that's looking pretty good. From the top. Over 100 is pretty good. Can we do better? Sorry about the movement. Trying to keep the camera and the drive aligned at the same time. Yeah. 120. I pumped it way too far there. See that? Sure doesn't take much. Let's go back. It's looking pretty good there. Tighten this down a bit. Reads are looking good. No failures or retries yet. Okay, that was a full successful read. Now let me see if I can make this signal a little stronger by turning the stepper motor a little bit more this way. And if not, I know where to roll it back to. So we get over 100. Ooh, look at that. 120, yeah. Okay, let me keep going. Turn more. 110. Okay, I feel like just a little back was the sweet spot. Yeah, that's looking pretty good. Let me try. Okay, let's go back to the top. Yeah, there. Look at that, 120 something. Okay, so it's good to re-seek after making adjustment. That makes sense. So let's go just a tiny bit. It really doesn't take like barely a millimeter. 120 again. I'm gonna try one a little bit more. All right, there. No, I think where I had it was about as good as it was gonna get. Ugh, that might be a little far. I'm gonna stick with that. Look at that. That's really nice. Okay, awesome. Let's just make sure that goes all the way down, all the way through. Okay, still over 100 at track 40. I think that's awesome. Unknown mark right toward the end. That's interesting. So I might want to pay attention to that. Let's do one more run. Yeah, unknown mark. All right. Let me move this a tiny bit more this way and see if that has any difference on, if like it's an alignment thing. I might have gone too far. Let's see. Yeah, there we go. Oh no, there's our unknown mark again. Okay. Okay, I'm gonna try adjusting the head, even though it might be a bad idea. Let's just see if I just move it a tiny bit. Yeah. Couple more unknown mark. Okay, let me try to stepper motor adjust again, ever so. Problem is I'm not sure exactly which thing to adjust at this point. Okay, I got two like unknown mark just at the very end. Let's try the beginning. Oh, I had 130 there for a second. So let's try one more, a little bit more this way. That was barely a nudge. Signal says still good on the 120s. Let's try the last 10 tracks here. Hey, there we go. Okay. All sectors found. I'm going to do one more run, full run of this reading the disc. Let's see how we do. Awesome. 100% read. I'm calling this pretty well calibrated now. Let's see if I can just turn those. Yeah, those are okay. I'll tighten this up too. And, well, there's one more question, which is, what about the whole bottom? The bottom head. Let's just see where we're at. I think it's going to be a huge failure, but let's see. Oh, boy. Yeah, I don't even know where to start. I'm at least happy to say I've got a read on the top head. It's been calibrated, signal's good. I'm a happy guy. I just realized something. I can write to disks the same way that I've been reading by writing only one head at a time. So if I write the bottom head, if I try to write, rather, to the bottom head, and this is on a test disk, not a commercial. Here we are trying to write and are getting unknown mark and then it fails. Now if I try the top head, aha, look at that. It's working. So this is really interesting because this suggests that the bottom head may actually just be bad or failing. I've already tested swapping these connectors from the heads through the amplification path, and that doesn't seem to make a difference. So I think that stuff is working fine. So unfortunately, I think the real problem here is the bottom head is faulty. And I do think when I first got this drive, the reading on the bottom head was working, but the write was not. And now it seems like both read and write on the bottom head are failing. So either there's some mechanical issue or it's not making contact. Darn it. I feel like I'm really close on this one. Okay. This drive just complained about writing the last 77 and 78 failed, complained and gave up, but real close. So let's, if I try writing everything, it's just gonna fail. It's the bottom. So just to take another look. So if I just write the top head, right into the top, we see pretty strong signal, which is awesome. If I try writing with no verify, we don't read back. I'm not sure exactly how this works. Like if the drive is showing what it's reading or writing. Not sure what's coming back in the test points, but it's interesting. And because it isn't reading, stop me to read it, it certainly moves faster. So if I try the bottom head, what happens? Yeah, and so you see the peak to peak on that signal is really weak. So I am a little confused. I feel like the head's not, unless it's failed, I don't think so. I think it's just like it isn't making contact with the disc or something. Although, I don't know, that doesn't make sense either. Mystery. Well, I'm afraid it's not looking very good for this stepper motor. The worm drive, if you want to call it that. So I took the back plate off of here, 2 screws to loosen the motor. Had to do a little work to wedge that out of there. It's probably going to be darn near impossible to see, but there are a couple of little ball bearings in the end of where this motor gear runs to. So if you're taking apart one of these drives, keep an eye out for those little ball bearings. Might pop out. Now, unfortunately for this motor, I don't think it'll show it. Can't really hear it, but you can just see there's some wiggle here, and that seems to be pretty generous. And depending on where this is sitting, it feels like it can bind. So I could take a look here at the innards, but I just get the feeling that this thing might be near the end of its days. I could try to clean out the inside, but I don't know if a little bit of oil might help. But I suspect that this thing is starting to have mechanical issues. So I guess worth a shot. Maybe this is a bit pitted and worn. Doesn't look too smooth. Maybe that doesn't matter. Again, I don't know. Not an expert, but I can try to use a small bit of sandpaper perhaps and see if that be smoothed out a little bit in case it's rubbing. Although that might make it wiggle more. I don't know. tough call. I just happen to have some sand wet 600 super fine sandpaper here, so I don't know. Again, feels like a crapshoot. Have I just made things worse? Only one way to find out. Should stepper motors be oiled, greased? I don't know. Machine oil. You can just see the amount of wiggle room that has. I don't like that. So I don't know if that's causing the binding, and then once that's happening, maybe there's nothing more to be done. Yeah, just gonna feel it kind of sticking. So I don't know, maybe that's where a little bit of lube, grease, oil would come in handy. All right, once again, try to clean this thing out. Then apply some grease, because why not? We'll grease up the whole thing. It's risky business, but I don't know. If this works, great. If it doesn't, fine. Okay, so that's that. Grease up the front side too. And then back in there she goes. And it ought to be plenty. I am not exactly sure how this thing was threaded. So this is also another question. So you see this, here's a good example of it in my poking around. Yeah. Just about lost the sort of ball bearing cap there on the end. So yeah, pay attention to that. That's for the end of the stepper motor worm drive shaft thing. That's a delicate little operation right there. All right, back in place. I've got this sort of threaded, and then I didn't show this. It's threading through. It's like a C fork shape like that. You can see why this is a delicate situation, because that also affects the alignment of the drive heads. I think this is looking okay. That's in place. So I'm going to try to lock in the drive. Hopefully that'll stay. All right, there's our whole track 0 sensor assembly. 0.5, yeah. 0.5 diode, so 0.5 volts maybe. Now it's also possible that this entire top assembly, actually this should be fine. I know that some folks have said this can affect reading discs and whatnot, so you could try bending these, but I think that's kind of dangerous. I think that portion, I mean, I could try that, but I don't think that's affecting this drive. I wonder if I lost a ball bearing and now I've messed up that, which would help explain some other issues. Okay, maybe I do want to be really careful with that. Let's try that again. Oh no. causing binding. I could take this out and see if it goes all the way back. Let's just try that. All right, now what? No. Okay, so there's something else is going on. Why would it stop there? Wonder if it's just the motor dying and it feels like it's physically stuck. Let's try moving this a bit more. No index. Yeah. Okay. So it's occurring to me that I should probably have this screwed in because the tiny steps are important. Otherwise this will just buzz. So this is loose dirt. That will also have an effect. So that's important. See it here. It's vibrating, but it's not turning. So I'm a little stumped. All right, one thing I'm really curious about, I've taken the stepper motor out. Does this just sit there and make binding sounds if I try to seek the drive? Aha. Yeah, there's your problem. It's done. Let's get one more last awesome shot of that thing failing. Oh, no. Okay, so I think the takeaway here is be careful. You know, don't use the screwdriver to try to pull that thing, because ultimately, you know, the end of this, that might be a little, it's not clear. There might be a tiny ball bearing or something in the end of that. But if you lose that, then mechanically this is not stable and you're going to have all kinds of problems. So I think it's time to, somebody should call boys to men, because it's the end of the road for this disk drive. Oh my God, what now? Oh no. Oh, okay, right, I've messed up everything mechanically, so let's reseat that on the bottom. Oh no. Okay, let's reseat. Whew, okay. Thank goodness. Well, it's been fun, but time to call it. This drive is done. Or at least I can say, I'm done with this drive. But I've learned a lot between, got the right head, confirmed the right works on the top, bottom head read seems to be misaligned, bottom head right, I wasn't able to confirm if it worked. Stepper motor is now finally burned out or failed, so it's been good, but this drive was in a rough shape when I got it, and now it's in a slightly worse one, but so be it. So this was the AKAI MPC60 drive. Boo. So there we go. The end of my little adventure. Still fun though, I learned a lot. And I got some fun new toys to help debug other things. The original drum machine drive has failed. I got this $14 drive, if you can believe it, from Amazon. Lucky find, I guess. It's a nice, I believe, Sony 920, MPF 920. This drive is not too difficult to modify. I don't actually plan to use it, but I just want to see if I can get this drive working in the drum machine. So that's drive select 1, drive select 0. And you can see there a really small, that's a 000. So that's a 0 ohm surface mount resistor. So I need to remove that surface mount resistor from JC31 and move it next door to JC30 to get select 0. All right, today's adventure, working with very, very small surface mount components. First time, and just for comparison, look at that. I need to get that onto that.